Let me know if there was a problem. Okay, so the hype is definitely real in the data mesh, and probably that's one of the reasons that you guys are all here. If you have been in the data community, you probably have heard this word. AWS is talking about it. The Presto SQL, the database that Facebook uses, is talking about this. If you've been to a Databricks conferences or a Kafka conference last week or 2 weeks ago, they had a whole section on the data mesh and patterns with Kafka on the data mesh. Me and Storm and a couple of other people have been on multiple of our clients have been introducing this idea of a new way of looking at data in the enterprise over the past 3 years. If you look at the stuff that's online, there's a lot of high-level conversations about this, about the vision, especially because data mesh goes in the area of the organizational design. My hope from this talk today is to really give you a realistic, tangible example of how the data mesh implementation would look like. So the things that we're going to talk about. We are going to talk about what was the client. We are going to look at this implementation as a kind of a case study. We are going to talk about what is a data mesh and what are the principles of it. And through the lens of those principles, look at what actually happened. And then we're going to wrap up and give you some key takeaways that hopefully you can take from this call. So let's start with the client. This client was Fortune 100 US healthcare. This is originally a payer. If you have not been in the healthcare industry in US, that means insurance, the payer side, who is trying to grow into the provider side, as all of them do these days, because that will create more relationship with the customer. Similar to a lot of the enterprises in the Fortune 500, they have a digital incubator, which is like a separate arm from IT that does all the more innovative things about the digital experience of the customer. Of course, heavily regulated. You're talking about insurance plus health. I don't think it gets more regulated than that. And really interested in the conversion of cash to innovation. Like, how can we invest in something and do something different? As you will know more, this client is not new to cloud or not new to data, as you can imagine, of being in the scale of a Fortune 100 company. So how was the state before we even arrived? So you have a centralized data platform as a center of this. Storm, do you want to walk us through the situation? Because this even predates when I arrived on this account. Do you want to walk us through that?
Of course. The client, for most of their analytical purposes, used an established Oracle data warehouse with a traditional IT model. They also had even kind of like legacy data systems on mainframes, but that was sort of the expectation in the standard, was that I can go to a data warehouse, I get access to everything. This is how I use data at this company. However, there's a big initiative to move to the cloud, and there had been a lot of kind of investments and almost competing efforts because it's a very large company. Within the organization, different teams and different organizations were trying to build a platform to meet their needs. But they had so far not seen the results that they wanted out of this movement to the cloud. The other thing that's big contextually is that their early efforts for the cloud were really just almost like kind of copies of the data warehouse to the cloud for specific analytical teams. Kind of their business analysts and machine learning groups who needed data now to continue their workflow. The first attempts at kind of building this platform was kind of creating warehouses in the cloud and giving those analysts the experience they were already used to, which is a data warehouse where you can do anything you want in it. That being said, the governance and the security organizations were kind of concerned about just copying over that model because it's the public cloud. It's a very different security context. And they wanted to know what is better for kind of security. And that just sums up some of the context when we started.
Awesome. So this is not very, very different from a bunch of enterprises that you probably have seen. Oracle data warehouse, 40-year-olds of history of going to the design of this thing, and everyone relies on it. It's the de facto standard across the enterprise. Anyone who thinks about data is thinking about the warehouse, but that was not the innovative and the goal that the C-suite wanted to get the enterprise to. So what does this C-suite want in end of 2015, 2016? They wanted to think of data as an enabler for LHR. LHR, very buzzwordy in the health community, longitudinal health record, which basically means a system that can answer member-oriented questions. We can think about what would be a member-oriented question or a customer-oriented question. Has Sina ever had COVID? That's a member-oriented question. You can think of that's a very simple question, right? But think about all of the information that needs to come to that to even realize that this person, what was the diagnosis for this person? And if we didn't have a diagnosis because health data is distributed, how would we even have a good conclusion that this person has had COVID because of the kind of drugs that he has been using, or type of claims that he's processing, or a bunch of from other different data points getting to the conclusion? That is the North Star that the enterprise, similar to a lot of payer and provider insurance companies, want to get to. And you can see that LHR on the top of this diagram. As a mental model, this diagram can help a little bit about how the data mesh fits in the organizational structure. On the very top, you have applications that are the touch point to the customer. So you can think of the message that you get on your phone when your insurance premium goes up, or the emails that go to you, or the website that you have, or when you go to an insurance retail pre-COVID era to buy insurance, the application that the associate is using in the retail to sell you insurance. That would be the very, very top layer. Behind that, an LHR can really help a bunch of member-oriented questions, which the data comes from the domain of the data. So domains in this example would be claims, or member, or coverage, or drugs, which is getting the information from the cloud platforms. This is a pretty common scenario, and cloud platforms are trying to abstract the infra. So you can see on the text on the right, you can see what each of level of abstraction is trying to do, and what are they trying to abstract. This is the North Star that this data platform is trying to enable, that middle layer of the domains that you can see that called data platform, which is most of our work in these cases today that we're going to talk about in these two layers of the cloud platform to the data platform. One more thing about the context, which is about how are we being measured for success, how we define success in such a complex, multifaceted environment.
Yeah, so at the client, they had multiple ways and multiple sort of OKRs that they were measuring success of the data platform and other data initiatives. Earlier, I talked about data analysts and machine learning data scientists. It was very critical that they onboard data analysts and machine learning scientists to these new workflows in the cloud. So they had targets to kind of bring these teams from their business as usual workflow into the cloud. The other one was supporting key strategic initiatives. Sina mentioned kind of COVID vaccines. There's a longitudinal health record, but they would target these specific initiatives. They're very tied to the business value, and they would kind of invest specifically in ensuring that these data products could be built to meet those goals. But I would say overall, the biggest focus and sort of the measurements we saw the most of is trying to measure how many data assets were being moved from the warehouse on premise to the cloud. It's a big number and a big goal that they had for moving over like 1,000 assets during this time period. And it was a number that they really rallied many teams around and brought a lot of kind of effort and investment to try to hit those goals. But what we saw over time was that once we kind of got some maturity in bringing the most high priority data assets into the cloud and onto the platform, those other goals of supporting personas and supporting use cases, we wanted to focus on a lot more. And I think that's a key measure of success. And we'll talk about it later. When you're working on a kind of a data mesh engagement or data platform engagement, using kind of a variety of metrics beyond just the number and the volume of data you're using is essential to making sure that you're taking that product and platform mindset and building the right thing instead of over optimizing for hydration.
Exactly. So number one, bring it to the cloud. Number two, enable all the analysts and the machine learning data scientists so that they can answer questions like this. If you haven't been in a payroll provider, these are very typical questions. How can I reduce treatment costs? How can I reduce discharge costs? I didn't know this. Apparently, when you discharge a person and that person gets readmitted again, that's a huge cost to the payer side. Or COVID, we had a bunch of examples. Who's vaccinated, who's not, who has had a vaccine from member of the population analysis, where are we on that? So these are the kind of questions that this data on the cloud was supposed to answer for the, or provide the data so that those analysts could answer those questions. So we have set up the context. This was the client that we're going to talk about. Let's talk a little bit about what do we mean by data mesh. If you have been in the data community, you probably have heard of the warehouse and the data lakes. The data warehouse, this is like 40, 50-year-old paradigm. It's everywhere that you can see in the industry. Let's upfront design a unified model of the data for the enterprise, and then ask everyone to conform to this model. And then when people want to query that data, that's very simple. It's a very unified design model maintained by a central team. Data lake got popularized about 10, 15 years ago. Don't do that. It's very upfront. Don't do data warehousing because the pain point was the upfront upfront design of a central model, which stopped people from actually using it. It was not very easy for people who were onboarding data. Let's do data lake, which is just put it in the lake for now. Whoever wants to consume it later on, they have to go and figure out and cleanse it and understand how these different data assets connect to each other. The data mesh is trying to solve for the failure mode of these two modes, introduces a decentralized way around the domains to do the modeling. So we are not doing master data management anymore. We are also not just sending stuff to the lake. We are saying, do the modeling in the context of a domain, do DDD, domain-driven design, on the data, which seems like a very intuitive thing to do. And that at the core of it, that's the main message. So there are 4 things that will change if you apply this kind of mentality to data. Don't do a special data warehouse lake teams. Don't have those teams. Those teams are not going to be there anymore. Don't think of data as a byproduct of another application. So I have a claim processing, and whatever it spits out, that becomes your data, and then another team needs to now clean it up. Don't do that. I will talk more about this. Instead of having a lot of governance teams who are going to come in at the end cycle of your data and look at what have you done, and trying to see if you have broken any rules or any obligation that the enterprise has, and try to penalize you for that. Try to bring that governance up front. These are the main paradigms that the mesh is trying to solve. I see, Scott, you turn your video on. Is everything all right? Okay, okay. Usually when some of the hosts turns their video on, that means I'm going over. I'm not going over. It's 2:30 right now. All right. So the next thing. So these are the 4 things that the data mesh is trying to change. Instead of these 4 things, this is the principles that we are going to talk about: decentralized domain ownership, data as a product, self-service platform, and federated computational governance. The point of this talk is we are trying to say that these principles depend on each other, define them, and tell you that they heavily depend on each other. So decentralized domain ownership, which means allow the origin of the data to onboard the data to the enterprise. This really depends on, you can't really have this without thinking of product thinking and design thinking about the data. You can't really have design thinking and data as a product if you don't have a self-service platform that's abstracting out a lot of complexities. And you can't really have a self-service platform for your data needs if you have not baked in all the governance ideas under this platform. So these feel like a bunch of fancy words. We are gonna start breaking them down and give you real tangible examples of what that means, starting with the decentralized domain ownership. So what does that really mean? Oh, too much. There we go. Shift the responsibility from the analytics data from the centralized functional team like the data warehouse to the business domains where the data origins. So what does that mean in reality? Let's go back to the example of the COVID. Does this person has COVID? In order to answer that question, you need customer coverage, claims, pharmacy member, what kind of drugs, is this drug related to COVID, and all of the information you can assume is needed for answering such a question. In the today's land, so where does this coverage data come from? That probably comes from an insurance software package that they bought 40 years ago, right? Where does the pharmacy information come from? Some of that is industry standard. Some of that is information that our client has on its own. And if you map the systems who are generating this data, like the CRM or HIT or Go 365, these are package software or custom software who are creating this data. Think about a universe where the creators of this data are responsible for providing the analytical data for the analysts. This is definitely not the case today. Like this, if you look at the state of data at any large scale enterprise, you don't see that. Were we able to achieve at this level? No. What we did was we moved the needle in that direction, which by bringing the role of a data steward, which sits between these two layers, which is I understand the application data, the transactional system data. I'm going to help you certify, onboard, cleanse, tag the metadata for these data so you can create these data products. This North Star that we are describing here is very, very hard to do. And that was one of the main learning points of this, which is the hard part about this is the organizational aspect change and require a different mandate. The main learnings around this that we came to is you need a sponsorship for the enterprise when you want to change something at the organizational level. We, on these clients, we entered from the technology angle on the client. And as a result, we didn't have a lot of sponsorship on changing the mandate of the organization to move incentives to allow such a change on the organization side. However, we were able to do this on younger initiatives. The amount of inertia for these younger initiatives was much less, much lower, and the ones that we were able to do that on the younger initiatives. So this is the data. Don't do claims for insurance. Claims is a core and bread and butter and the history of insurance. For the other ones that were new, for example, I said this client was going to provider side. So those data sets were new, those assets were new, the organizations were new. It was much easier to incentivize them to own creation and providing their data to their user in a more cohesive way. So these are the main learning points from the domain-oriented decentralization. That's what this first principle means. But you can't really have this all of these domains of claims and customer and tell them, hey, from now on, go provide your data. You need to provide design some sort of a design thinking and product thinking about the data, which really brings us to the next point, which we talk about data as a product. What do we mean by data as a product? We are trying to encapsulate the data with code infrastructure. Today, if I tell you data, you think about a Parquet file or a CSV file or a table inside SQL. We are saying encapsulate this with the code that goes into transforming this data and the infrastructure that hosts this data and create this unit of encapsulation and think of it as a product, apply design thinking and product thinking to this unit. We do this all the time with other products that we create, right? You go through exploration, build, evolve on the cycle. Do the same thing for your data assets. This is, of course, a very new way of thinking about the data. People don't think about data this way. Think of data as usually is a byproduct of a transactional system. This is an example of a data product canvas for the COVAX. So you probably have seen product canvases for e-commerce, or for, if you think of like an order management system, or when you are doing a startup or a lean startup course, they will ask you to do the lean enterprise canvas. Similar ideas. Think about your customer. Who wants this data? So in this case, machine learning and the data scientists or the analysts people. What kind of data are they talking about? How much volume? What are the risks around this product? How are we going to evolve this? What's the roadmap for this data product? These kind of questions are things that will come up when you apply design thinking and product thinking to this. The things that we are encapsulating in these products are the data plus the policies plus the code plus the infrastructure that comes with it. This is a new unit of architecture in your data mesh architecture that encapsulates these four things. What do we mean by data? This is the bread and butter of what this whole platform is about. The data is what the data comes in and comes out. Think about COVAX. So COVID vaccine, what is the data comes in? Data comes in, some of that is the claims. Did I claim a lab result? Did I claim any kind of drugs? How often does the data come in? Do I get a full snapshot of the past 5 years? How does it come in? Is it this industrial standard FHIR data? Is it CSV file? Is it a Parquet file? Does it come as a real-time stream? And how does the consumer of this data wants to consume this? In what format? Do they need, for example, if you're coming from machine learning side, you probably need this data as Parquet, versus if you're coming from a SQL and an analyst side, as a citizen analyst of the enterprise, they probably are prefer to play with this data as SQL. But this is not, so we are trying to draw a line between data product as a new concept and data, which is a known concept. Now combine the data with the policies and the codes and the infrastructure. So what else are we encapsulating other than data? The policies. So you are getting all of this data, for example, that we just talked about, for example, for the COVAX claims or for the COVAX drugs, the policies that define the encryption rules, the de-identification rules, and what roles has access to this data. Can a machine learning data scientist see all of the data with all the PHI and PII information? Absolutely not. You cannot do that, give that data with 5 years of history to any machine learning data scientist. This sentence is a policy. We are definitely gonna encode this as a policy and combine it, encapsulate it with the rest of the data as a part of data products. The third thing, the code. These are all the codes that you write as a data engineer that does the processing of the inbound, the logic and the transformation, if you're massaging the data as going to the consumer, and the polyglot automation for the output. So if I'm getting the data as a Parquet file coming in, I might need to provide it in multiple different outputs to the customer based on their needs. This is the example, the main differentiation between analysts and the scientists that we talked about. And the last piece of this, which is the last but not least, is the infrastructure component of this data. So this is all the pipelines and all of those things. Over to you, Storm, to talk about our infrastructure encapsulation.
Sure. So when we thought about infrastructure, we wanted to support like atomic and autonomous, atomic and autonomous data products. So typically when you look at like the cloud offerings and services, they're designed to do a specific vertical function. And sometimes you have teams built around them. You have access teams, you have kind of specific compute and orchestration workflows. You have networking teams, things like that. What we wanted to make sure was, especially for these use cases for analysts and data scientists, that when they are kind of putting together their data product, they can provision all of these services and infrastructure components in a kind of secure and easy way. And this meant basically that we had large services that were maintained by a sort of an infrastructure and platform team. And within those multi-tenant services, we had least privilege access and functional independence so that the data products could exist as like this atomic unit. A big thing, or a lot of time we spent, was thinking about how do we kind of carve up and utilizes these infrastructure or platform as a service offerings from cloud providers to meet the needs of a data product and for these analysts and data scientists. We made sure that whenever we were kind of drawing these boundaries and provisioning the infrastructure, that they were least privilege access. This was particularly important in the healthcare context. We don't want kind of data shared in the same cloud infrastructure to kind of, people might need access to different things, and you don't want the decisions of where to host that to get in the way of kind of GDPR or HIPAA issues. So what we did was for some things, we created independent and isolated pieces of infrastructure like identity. In other cases, we used like shared storage accounts and shared Databricks workspaces, but then applied the appropriate access control mechanisms to ensure that these data products did exist as independent units. And we did spend a lot of engineering time on this. We found this to be a big challenge because we were trying to balance these goals of having a kind of functionally independent data product with the reality that there's a lot of cost and scaling limitations if you over-index on kind of giving every domain or every data product their own set of infrastructure. So theoretically, if you had no limits and no costs, you could do things like ensure that every data product is provisioned with like a blueprint or its own set of infrastructure. But we ended up doing a lot of work on the platform side to kind of manage multi-tenancy infrastructure and ensure that people using that infrastructure used it in such a way that they felt like they were using a singular data product and not a huge storage account with 500 data products. But I think this point in particular points to some of the reality that when you're trying to take the current data warehouse or data lake paradigm and mix it together with data as a product and domain ownership, they're not necessarily made for each other. In our case, we ended up building a lot of custom software to meet those needs. But this is really why we have a self-serve platform. And Sina is going to explain a little more what does that really mean. Oh, I apologize. In terms of data as a product, as we talked about at the beginning, we had specific goals around kind of meeting analyst needs, but also hydrating data to the lake. In any engagement or any initiative, measurement matters. Using product thinking to measure based on the value of data as opposed to just kind of the number of data assets you move is going to make sure that your technical investments provide kind of a good return for your business needs. And product thinking means that you're looking at things in a different way. You're not only looking at kind of features and the needs of people who have the data, but you're also thinking about data as a product, as something that can be packaged, deployed, and used more independently than like a big data lake team.
Exactly. So far, we have encapsulated the data and policies and the infrastructure into a single unit. If you look underneath of all of these four things encapsulated, it looks pretty nasty and ugly because you have all of these different rules and across different Azure resources, or we are using Azure or any other cloud resources. And this is which makes the need for, if you don't have a self-service platform and you're asking each domain to go and figure all of this out by themselves is going to be a recipe for disaster. And that's the next section, which is the self-service platforms, which try to remove the complexity from these domain teams so they can focus really on the thing that they are really good at. If the claims team is really good at claims data, don't ask them to solve infrastructure, policy, and Azure networking challenges. So there are two separate groups of products that we can talk about. The kind of products that go across all of the mesh of the data products, and a separate group which is talking about an individual data products lifecycle. The first group is probably a little bit easier to start with, so let's start there. You can think of these the products like discoverability or observability or admin console. If you think about discoverability, I want to see what is on this platform. I want to be able to search. I want to see things. Observability, I want to see the health of my platform. On admin console, I want to change the data, the policy and access requirements for different people and different roles. A discoverability tool would look like something like this. I should be able to search for an asset, see the results, be able to explore the schemas, be able to see the preview of the data. There are definitely a bunch of tools on the market like Atlas and Purview around this. We rolled out our own because none of them really matched the kind of things that this client really wanted to do with their data. An example of what these tools could not give us is making data actionable. Okay, so I searched for claims, I found the claims, I want to do something with it. So this is, for example, on the left, you can see I want to select it and I want to launch it in a reporting tool or a Looker or a Power BI, or I want to launch in a Databricks. You can see a sample Databricks that will open for you. If you say, I think this is the data I want, let me play around a little bit with it in Databricks to make sure it is the one. Or tools around observability. For Kovacs, we said that it depends on 26 different data assets. What are the health of those? Is the data available? When was the last time it was refreshed? Again, tons of tools on the market. We went with Azure Log Analytics as it was the easiest tool to provide such kind of reporting. And Admin Console, which is I want to be able to manage access to the different output ports, and I want to be able to manage who actually has edit access on these data products now that we have encapsulated them in a single unit. Other tools that on the market do the similar things, Privacera and the Ranger, which is actually Privacera is a wrapper around Ranger, that do very acting in the similar way. We couldn't use them again because of heavy regulation. In healthcare, there's a bunch of contractual obligations that we can't. Our client wasn't ready to jump into these tools, and we had to hand roll a lot of these ourselves. The other set of products are things that are managing a life cycle of a data product. I'm going to talk mostly about the core, which is the main domain of a data mesh. So a core is trying to abstract away from managing the lifecycle. On the left, you can see a CLI command line that you can go and play around and create any data products. On the right, you can see the declarative language that we created to create a data product. So you, in a high-level language, you would say, for Kovacs, I need these kind of data sets as my input, and I need to be able to have this kind of data sets as my output. And with the left side, on the CLI side, you can say, okay, now go and create this for me, deploy this in a staging for me, and actually run it. So with the CLI, you're managing the lifecycle, and with the spec, you're declaratively defining. This abstraction that we're talking about is the thing that is going to hide the complexity of the infrastructure, hide the complexity of the policies from the user, to allow claims domain to focus on the claims stuff and not on the Azure stuff. If you want to go a little bit deeper of what this looks like, this is the kind of APIs I provide. You can see, give me all the data products, give me the specific version, or create a data product by a post, or I want to get all the deployments. Where is this data product deployed in all of the environments that I have, or create a new deployment, or run a data product that is already deployed and has a physical manifestation on one of the cloud environments. The main learnings around this is building these self platforms are the core way to hide that complexity and remove that friction. And you also need to provide a lot of, what we found very useful is because the mesh is a new architecture, is a paradigm shift in how we think about data. It's very, very important that you create some dotted line from the familiar concepts in people's heads to these new concepts. So for example, we found, if you saw this example, this CLI experience is very similar to an NPM file. Or when we talked about sharing and managing access, it's very similar to how you would share a Google Doc on Google Drive. You can share it with your friends, or you can share a data product or share data with your colleagues on the enterprise. Having said all of this about self-serve platform, none of this is possible if you have not built in governance inside your product. These data, as you can see, these claims data all are full of PHI and PII information. How can you guarantee that this platform is secure is the federated computational governance, which Storm is going to walk you through.
Yeah, so to start off, I'm just going to define what do each of these terms mean. Governance is establishing standards of how business and technical metadata to catalog, secure, manage access. Federated is about decentralized responsibility, about how you do governance. And then computational is about automation. It's about, instead of somebody manually auditing, you have detection methods in your CI/CD pipeline, and you have corrections automatically applied. So in our context, federated computational governance focused a lot on platform automation of policies to ensure data was secure in the cloud. We also did some work about trying to orient towards a common schema language and a metadata catalog, but we focused a lot of our efforts here on the security aspect because, as Sina mentioned, we're in the healthcare space, and it's essential that you are complying and managing those risks while you're also delivering value with data. So a little context on what governance was like. You sort of had separate vertical teams for governance, separate teams for data warehouse and data lakes, and then you also had the analysts and data scientists who are the customers. The governance orgs really wanted to use the cloud migration opportunity as a way to apply best practices for security and identity and access management. This was kind of their first big move to the cloud as an organization beyond just like a digital incubator piece. So there was ambiguity about what are the right standards for this organization to use the cloud. Like, are the offerings from kind of this cloud provider good enough, or do we need to implement additional protections and mechanisms so that we have confidence in giving our developers kind of the reins to do what they need? And governance also worked a lot as a gatekeeper for the development process, and not necessarily an enabler at first, because there's such a high cost to mistakes in this case, and it's a very complex space in a big organization. These governance organizations focus on being gatekeepers because it's so much harder to try to monitor, audit, and remediate when you've let the cat out of the bag. So that's sort of the context we were working into. And I'd also say it's probably governance was the biggest blocker and then the biggest enabler of our ability to meet those metrics of success, which were kind of bringing data assets into the platform and giving analysts and data scientists what they want. When we started out, there's a lot of concern about putting sensitive data in the cloud, which that limited the number of data sets we could kind of move over and create value out of the platform. And it also gave those customers kind of a subpar experience. They were getting de-identified data. So a lot of them would look at it and say, why would I move my workflow over when I can get kind of more rich, easier to use data on premise because I don't have to worry about these new cloud security policies. So we invested a lot of effort into making sure that we turned governance from a blocker to an enabler. And what we did was we kind of worked with those organizations which are more centralized in nature than maybe a federated model that the data mesh espouses and aims for. But we took their policies, understood what good looked like for protection, for like encryption, networking, access management. And then we used kind of the self-serve platform as a vehicle to package it all together and build guardrails so that when a team builds a data product, they get all of that stuff out of the box, and you're dramatically decreasing the headaches of each individual team doesn't have to deal with all the complexity of these requirements. And the governance organization feels a lot more secure knowing that these policies are automated and that they don't have to invest as much time in sort of like auditing and restricting development. So the investment in the self-serve platform and the partnership with the governance teams really shifted the incentives of the organization from governance as like a burdensome compliance activity that would get in the way of delivering value to an operational activity that could be kind of utilized with simple metadata or simpler developer commands. And really quickly, we worked with these central orgs to define the thinnest possible thing for global policies that created a floor for what governance looked like on the platform, and then leveraged the self-serve platform so that you can enable these data product and domain teams.
So we talked about these 4 principles, and for each of them, we went a little bit deeper on what it really meant on the ground. Let's bring it all back together. Data mesh, a new way of looking at data enterprise. 4 principles: decentralized domain ownership, allow the origin of the data to be responsible for providing it to the rest of our organization, which relies on thinking of data as a product, which means do design thinking about data. It's not just a byproduct, and it encapsulates data plus the code, plus the policy, plus the infrastructure, all as a single unit, which relies on having self-service platforms that are abstracting all of that complexity and friction out of these domain teams so that they can do that product thinking, which relies on federated computational governance. We talk mostly about the computational governance, not the federated part, but without that automated governance, none of these things will even see the light of the production and will never be successful. If you want to learn more about this, as I said, the buzz is real. If you join any of the online forums about this, you can see tons of information. The Starburst is putting a lot of community-driven activities together. There is Data Mesh Foundation also, which has a 500 plus last time I looked at data engineers and data scientists who are active. Thoughtworks website also has a good hub of all the resources that are related to this area. And Jahan, the creator of the founder of the Data Mesh, also is publishing a book. A bunch of the chapters are already available online. If you want to take a look at the early release. And with that, we're gonna wrap up. Thank you very much for your time.